So now we're going to look at equations of lines that are perpendicular. So we just finished up parallel. Now we're going to look at perpendicular lines. Pretty much the same reasons, using slope to figure out perpendicular lines and write equations that pass through a given point. It's going to help you with tangents, derivatives, and quadrilaterals when we get to that in a future unit. And when you can identify perpendicular lines from an equation, you know you got it. So let's start just by graphing these two lines. One of them is already in slope-intercept form, so we'll start with that. Two x plus 5 means you start at 5 on the y-axis. That's your y-intercept. And then the 2 tells you that your slope is 2. So it's going to go up 2 over 1. If you wanted to continue it the other way, you can go down 2 left 1 and get a whole lot more points. A similar process with the second one, but we need to first make that be slope-intercept form. We're going to solve for y. So that means we subtract 4x. And then to get y by itself, you now divide negative 4 divided by 8. You can reduce that to negative 1/2. And then 24 divided by 8 is 3. So now we can graph this green equation. We're going to start at the 3. That's our y-intercept. And then we're going to use the slope, negative 1 over 2, to go down 1 over 2, down 1 over 2. You can continue it the other way. And now clearly you can see that these are not parallel. They do intersect, but if you really, really wanted to get precise with it, we can see that they are intersecting at a right angle. They are intersecting at a right angle right there, which means that those lines are perpendicular. So when we talked about parallel lines, we talked about how their slopes were the exact same. Now we're looking at these lines, which are perpendicular. And we had a slope of 2 and a slope of negative 1 over 2. Slope of 2 and a slope of negative 1 over 2. That means you got one positive and one negative. And the numbers are actually flipped. Like it should be like 2 over 1 to flip it to become 1 over 2. So you flip it and you change the sign. So perpendicular lines intersect to form right angles. Their rate of change is completely flipped and opposite. And then the fancy vocab for that is that their slopes are opposite, which means the same thing basically as negative, and then reciprocal, which means you flip the fraction. So you flip the fraction, and you change the sign. And that's how you know that two lines, just by looking at their slopes, they are perpendicular if the fractions are flipped and the signs are changed. So now we're going to do an equation that is perpendicular to the given purple line, and it has to pass through this point. So the first thing we're going to do is we're going to look at the slope of that given line, the purple line. So you got to find two good points. So between these points, that slope is, it goes up 1 over 3. Up 1 over 3. So that means that your perpendicular slope, that little upside down capital T, that's a symbol for perpendicular. You need to flip the fraction and change the sign. So we're going to flip 1 over 3 to become 3 over 1. And you have to change the sign because you're doing the opposite reciprocal. So it was positive, you change it to negative. So negative 3 over 1, going from this point. Negative 3 over 1, you go down 3 over 1. Down 3 over 1. If you wanted to continue it the other way, you could go up 3 left 1. So that's our perpendicular line. Now, we want to write the equation. The downside so far is that it hasn't crossed our y-intercept. It has not crossed the y-axis. But you could figure it out if you just continue our slope again. It was down 3 over 1, down 3 over 1. So it's going to cross at that next point off the graph. This is negative 6, negative 7, so that's negative 8. So your equation, y equals mx plus b. B is the y-intercept, negative 8. And then our slope was negative 3 over 1. It's just negative 3. So you can do the same type of equation, the same type of process without the graph if you just use point slope form. Here's our x1, y1. And we're trying to go perpendicular to this equation. So we're going to start by finding the slope of this equation. So getting y by itself. So we're going to subtract x from each side. We're going to divide by negative 3. And you get y equals, negative over negative is positive, 1 over 3, x. And then positive over negative is negative, 2/3. So our slope from this original equation is 1/3. Which means we need to find the perpendicular. We're going to flip it and change the sign. So 1 over 3 flips to be 3 over 1. Change the sign from positive to negative. That's the slope we're going to use for the equation. So negative 3 over 1 is just negative 3. So we're going to take that into point slope form. we know the slope is going to be -3, and then we know our x1, y1 from over here. So that's y minus -4, x minus -1. And we just need to do the algebra to simplify this. So 2 negatives turns to plus. And distribute that. -3 times 1 is -3. And finish it off by subtracting 4 to get y by itself. -3 minus 4 is -7. So there's our perpendicular equation that passes through -1, -4. Y equals -3x minus 7.